wife bought my daughter an Old Navy t-shirt that had this logo on it. Never forget Pluto, 1930 to 2006. And so my daughter was wearing it out. We were out in public one day, grocery shopping, something like that. We ran into a woman, and she looked at my daughter and she said, "Oh my goodness, you are so cute. Let me look at that shirt." She said, "Never forget Pluto." My goodness, did something happen to Pluto? Yeah, actually it did. In 2006, the International Astronomical Union demoted Pluto from a planet to a dwarf planet. So in this video, we're going to explore Pluto's discovery and learn why it's no longer considered a planet. Now our story begins in Flagstaff, Arizona. Pluto was actually first identified there by a man named Clyde Tombaugh in the 1930s. 1930 to be specific in this case. And what Tombaugh had noticed was that there was a teeny little point of light. You can see that with the little yellow arrow that's right here. It moved from B3, this teeny little dot, moved from B3 to C, well, between 2 and 3, right on that green line right there, over the span of several days, 7 in this particular instance here. And it was this movement that led astronomers to recognize that there was a new planet that was out there. As a result, we got this great little acronym to remember the 9 planets, the now 9 planets that had been discovered at this point, right? My very excellent mother just served us 9 pizzas. It stands for Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then finally Pluto. In the 70 or so years since Pluto's discovery, what have we really discovered? We've learned a lot about Pluto, as a matter of fact. Really from like 1930 to 2000, we know that it exists in the Kuiper Belt, which is kind of like the asteroid belt. It's a bit bigger, but it's really far away from the Earth, so a lot of rocky bodies that are sort of in the way. We know that it's a bit smaller than Mercury. As a matter of fact, it's even smaller than our moon. It's about 66% of the size of our moon. We know that on average, it's about 35 astronomical units away from the sun. For reference, Earth is 1 astronomical unit away from the sun. So this is basically telling us that on average, Pluto is about 35 times further away from the sun than we are. Speaking of surface, we know that it's pretty rocky, and we know that it takes a little less than 250 years to orbit the sun. Now this little blurry image that you see down here in the lower right-hand corner, this was taken by the Hubble Space Telescope in the early 2000s. And I have to point out, it's blurry because we really had limited technology back then, and it wasn't until the New Horizons space probe actually passed by Pluto in 2015 where we were able to get some pretty good crystal clear images of this. But this is about as much as we could really get or learn about Pluto as it relates to this problem. Now, the big turning point for Pluto occurred kind of in the early 2000s. Now, what happened around this time was the discovery of a couple new bodies. The 2 that are of note are this one over here. This is Sedna. This is the little red one that's right here. We don't know what Sedna actually looks like, so this is sort of an artistic impression of what we think it probably looks like. And then Eris. When Eris was discovered, scientists thought this was actually a body that was a little bit bigger than Pluto. And so this presented a big problem in the astronomy community. With the discovery of Eris, does that mean that we are going to start classifying Eris as a planet? And if so, do we have a 10th planet basically in our solar system? And better yet, what happens when we discover the next one? How are we going to increase the number of our planets now? But nevertheless, there was some really heavy discussion over how do we actually want to classify a planet. We have a lot better information about Sedna and Eris, and we know that they're actually quite smaller relative to Pluto here. But nevertheless, when they were discovered, it really kind of kickstarted this really controversial academic debate over what it meant to be a planet. So a few years have passed since Sedna and Eris were discovered, and there was a lot of intense debate over what it meant to be a planet. The International Astronomical Union started soliciting opinions from experts in the field, right? So they were looking at people that were obviously astronomers, but linguists and other relevant experts. They basically had come up with a set of criteria that would be needed in order to become a planet. Number 1, that object has to be able to orbit the sun. Number 2, it has to be large enough to possess a round shape. Now the third one is the really controversial one. The body must possess dynamical dominance in the orbit. A planet has to be the biggest object in its orbit, and there's got to be very little debris in its way. And so what astronomers oftentimes will refer to is that planetary body, is it clearing the neighborhood, in other words? So if you removed all of the debris from the planet's orbit. Now, if you cannot meet this bar, you're not considered a planet. By definition, you are considered a dwarf planet, and that was what happened to Pluto right here. So the definition was proposed, and then a final vote was actually held during the 2006 IAU conference in Prague, and the consensus vote was to formally acknowledge these three criteria be applied when assessing whether or not an object is a planet. Suddenly, after this vote, Pluto was no longer considered a planet. It was considered a dwarf planet. Now, what is meant by dynamical dominance? Let's explore this idea in a little more detail. In this first image, there is a green sphere that represents a planet like Earth or Jupiter. Now, the little spheres that are surrounding it are really rocky debris in the planet's orbit. But because the pathway is essentially clear, the green sphere dominates the planet's orbit. In other words, it has cleared the neighborhood of all rocky debris, meaning that it would be classified as a planet according to the 2006 IAU definition. Now, the second image shows a white sphere which represents celestial objects like Pluto. Since there are several teeny little spheres that are in the way of the planet's orbit, the white sphere would not be classified as a planet according to the 2006 IAU definition. Now, when we apply dynamical dominance to Earth and to Pluto, what do we see? Now, Earth has a teeny little bit of debris that's actually in its way right there. So it is experiencing dynamical dominance. It has cleared basically most of its orbits. There is some stuff that's sort of in our way, but for the most part, nearly 100% of the mass in Earth's orbit is actually contained in Earth. This is different than Pluto, so it has a non-dynamical dominance. In other words, it hasn't cleared its pathway. See all the little dots that are there, the black dots? They are orbiting the sun just like Pluto. And as a consequence to that, that is the criterion that the IAU used to determine what was and what wasn't a planet. This bar graph shows the 8 main planets as well as Ceres, Pluto, and Eris. Now, for all 8 planets, nearly all the mass in the body's pathway is contained within the planet. That's symbolized with the blue bar. So you look at any of these planets that you want to, very large blue bar that's right there. A planet's orbit is never entirely clear of debris. For planets, the mass of the debris in the path is so small compared to the planet's mass that we can actually say that the planet's orbit is effectively clear. Now, if we take a look at Pluto, you'll see that the blue bar is really, really small. What this means is that Pluto's mass is quite small relative to the debris and the path. Both Eris and Pluto contain less than 10% of the entire mass in its orbit. Approximately 90% of the mass in Pluto and Eris's orbit is debris, and that's the fascinating thing about what makes these dwarf planets a bit different than the 8 main 9 planets right there. Now, similarly, you'll notice that Ceres has a little less debris in its path relative to Pluto and Eris. Based on the 2006 IAU dynamical dominance standard, Ceres has a way better chance of becoming classified as a planet than Pluto and Eris. So to date, there's still some controversy over Pluto's status. See, some astronomers are clinging to this whole 2006 IAU definition, indicating that Pluto is actually considered a dwarf planet. Other astronomers, and I'll point out our friends at the Auburn Astronomical Society down in Auburn, Alabama, firmly continue to recognize Pluto as a planet. In other words, I don't think this debate's over quite yet. First, the IAU definition was passed by over 400 astronomer votes, but the Pluto is a planet people point out that that number only represents about 5% of all astronomers on Earth. Now, the question is that a fair representation of the broad astronomy community? Second, although people who contend that Pluto is a planet note that dynamical dominance is a reasonable metric for classifying a planet, pro-Pluto as a planet people, that's a tongue twister, have raised concerns over what the dividing line is between dynamical dominance and non-dynamical dominance. In other words, what's the magic number? Where does the tipping point kind of happen? Another interesting point of contention is over having 8 planets in the solar system. Some pro-dwarf planet educators have noted that 8 is a manageable number, and removing the dynamical dominance argument means that the solar system would suddenly balloon from 8 planets to over 50 planets. The pro-Pluto as a planet people note that the science doesn't care. It doesn't matter how many planets there are. We need to come up with a reasonable argument. So the debate isn't over. That's my main point. You may find in your lifetime that they may revisit this argument again. Now the question remains, should we be using dynamical dominance as a criterion for classifying a planet? What do you think?